So a couple of things about this assignment is that even if you look at starting with question number 21 and make sure everybody's cool with this. So on 21, you've got an electron is moving in a circular orbit in the Earth's magnetic field directly above the north magnetic pole. Viewed from above, is the rotation clockwise or counterclockwise? Okay? So here's the first thing that you have to remember. Here's the Earth, and here's the internal magnetic field. When you look at the internal magnetic field, is that the South Pole or the North Pole that's actually at the North Pole? The South Pole. Now, which direction do magnetic field lines move? North to south or south to north? North to south. So these field lines are coming around like this. Okay? So when this field line is coming into the North Pole, it's headed down. So there's a couple of things that make this problem require thought. First off, the magnetic field line is coming down. It's moving in a circular path. So which direction does the force have to act? Inward. And it's an electron. Okay? So there's a whole bunch of things you have to think three-dimensionally on that first question. But just remember, the North Pole is the South Pole. When you get to question or problem number 27, and it's a little bit weird how you have to do this problem. So you got to move on. A charged particle's mass between that of an electron and proton follows a circular orbit in the Earth's 50 microtesla field at a frequency of 6.8 kilohertz. Okay? Then it says, now what frequency would a muon orbit in Jupiter's more intense 430 microtesla field? To make that comparison, you have to assume that they're orbiting at the same radius. Okay? They don't explicitly tell you that, but that's the only way you can make a comparison. So on 27, okay, you have to assume that when you take that same particle and you move it to Jupiter, that it's orbiting at the exact same radius that it is on Earth. When you get to 45, 45 actually involves circuits, okay? So you got to go old school circuits, find the current. You got to use that formula with the wires. When you get to 46, okay? So on 46, you have an electron. This is where somebody had mentioned electric fields. 46 involves electric fields. So you have a positively charged plate at the top and a negatively charged plate at the bottom. You're shooting, in this case, an electron through there. Okay, you're shooting an electron through an electric field. So it says what magnetic field strength and in what direction will allow the electron to pass between the plates without being deflected. So start with this idea. Here's the electron going through this thing. Which direction, just based upon the electric field, is the electron going to move? Up towards the positive, down towards the negative?
Up towards the positive.
So the electric field force is going to be pointing up. What's the only way you can balance that then?
Have a magnetic field going down.
Have an equal magnetic field going down. But, again, you got to think three-dimensionally. Okay, right. I got an electron going in this way. I want a force that's going to push it down. Which direction is the magnetic field going to point? So let me give you a hint on that one. The direction of that magnetic field on 46 is either going to be into the page or out of the page. It's not going to be up or down. So the magnetic field is either going to be pointing in or it's going to be pointing out. Okay, not up or down. It's either an innie or it's an outie. Your answer on 46 should start with a 2. Okay? Should start with a 2. On 48, it asks about something called a railgun. So a railgun is basically a very high energetic way to accelerate a charged particle using a magnetic field. So if your answer to 48A is wrong, everything else is going to be wrong. So your answer to 48A should be around 1400 amps.
Oh my gosh.
Yeah.
That's
If you consider household amps are usually around 15, this is around 1400.
For which problem?
48A, because if your amps are wrong, everything else is going to be wrong. Okay?
rookie numbers.
I'm just telling you.
Wait till we get
Okay,
to
now on the 3 gambling questions, as Connor S. put it, okay? So I beg of you, you have to pay attention to what these particles are. So on this first question, you have an electron is traveling through a region of space with a magnetic field in the negative z direction. So let's start with this. If you look at the diagram, notice that they've got that positive z with a dot. So the positive z has the dot, which means what? Which direction is it going? Out. So negative z would be into the page. Okay? So just keep that in mind. When you get to that third question, it's another electron. Okay? It's another electron. Just keep that in mind. Okay. You're on your own. Good luck.
Unless you need it.
Danny, stop. You're on the camera.